All right, so today what we're doing is we're kind of switching away from sequences and series. This first chapter, like I've said before, is kind of random. There's a lot of random stuff in here. But the next section is solving equations by graphing. So we're going back to graphing today. So whenever we're solving an equation by graphing, basically what we want to do is we're given like one equation equals another equation. So like something equals something. Well, we want to graph the equation on one side, and then we want to graph the equation on the other side. So we're going to graph both of them. And then the point where those graphs intersect is going to be our solution point. Okay, so our solution point, it is going to be an x and a y coordinate. So we're going to need to write it. It's not just the x, it's not just the y. But so the solution point is where they intersect, and you would just write the coordinate for that, like the xy coordinate. So my example, it says I have negative 3x plus 20 is going to equal 5. So I need to graph negative 3x plus 20, and I need to graph 5. So to graph negative 3x plus 20, where would that y-intercept be? Jace, what do you think? So if I have negative 3x plus 20, if I think about y equals mx plus b, what's my b value?
20.
Yeah, 20. So my y-intercept's just going to be up here at 20. So I'm just going to go by 5s. So here I am up at 20. So my y-intercept is up at 20. Okay, so now I have negative 3x. So my slope I know is going to be negative 3. So to graph negative 3 by hand, Trey, how do I do that? Yeah, down 3 over 1, okay? So I can come, so if I go over 1, I'm gonna go down 3. So here, I now would be at 1, and then my y coordinate would be 17. So here I am at 1, 17. Okay, so now I can go over 1, down 3 again. So if I'm at 2, now I'll be at, what'd you say?
14.
Yeah, 14, thanks Grant. Okay, then when I'm at 3, Grant, where would that one be?
11.
Yeah, 3, 11, okay, so about there. Keep going, Grant, what would my next one be?
8.
Okay, so I'd be at 4, 8, and what about at 5?
5.
Yeah, 5, 5, okay, so, okay, so here's a couple of points for us, okay? Again, my graphs are not perfect. You guys don't make fun of them. They were really bad this morning, so hopefully they're a little better this afternoon. But here's my line. See if I can hit most of those points. Okay, so here's my graph. This is negative 3x plus 20. That's the graph of that right there. Okay, so I have quite a few points. Now let's go ahead, let's graph our other one. So if I have just 5 over on this side, how do I graph the line 5? Jaden? Yeah. Yep, I'm just gonna have a horizontal line at 5. So just a straight horizontal line at 5. Okay, so here's my line of just y equals 5. Now, do you guys see where the two lines are gonna intersect each other?
Yes.
Yes, so what would my solution be?
5,
Kenny,
5.
what do you think?
5, 5.
Thank you. Thanks, Grant, too. Yep, so my solution would be at 5, 5, because that's where those two graphs intersect each other. Is everyone okay with this first example? You guys can graph two lines and see where they intersect? Yeah. Okay. Let's go ahead, let's do another one, you guys. This one's a little bit more complicated, but we're gonna do the same exact thing. We're gonna graph one side, then we're gonna graph the other, and then we're gonna see where they intersect. Okay? So, all right, so do you wanna graph the absolute value of x minus 4 first, or 1/2 x plus 1? It makes no difference.
1/2. Just because
Zane, what'd you say? The x minus 4, okay. So if it's the x minus 4, we know that that's an absolute value graph, so it looks like a V. And then where is that graph shifted? Owen, what do you think?
To the right 4.
To the right 4? Yeah, because it's the minus, so I'm going to come over 4. So my vertex usually is at 0, 0, but I'm going just to the right 4, okay? Now, how do I figure out where my other points are for absolute value of x minus 4? What's my slope for that one going to be? Damien? A half. Oh, so we're looking at this one over here still. So, yeah, just 1, because it's just x. So, yep, so my slope is just going to be 1. So, I can go ahead, let's plot some points, and let's take this one all the way out to 10. Okay, so if I start plotting these in a V, I know if I come back, so I have this side of my V, the side going down, and then the side going up. So over here, I'm going to be at 3, 1. Then I'm also going to be at 2, 2. I can be at 1, 3, 4, 0, and so forth. Okay, so here's half of my V. Okay, so something like this. Not the best points, but close enough. Okay, and then over here, we said our slope was 1, so I can be at 5, 1, 6, 2, 7, 3, I'm up here at 8, 4, 9, 5, and 10, 6, okay? And then here's my other half of my V. Are you guys okay with that absolute value graph?
No, absolutely not.
You guys can graph that on your own if I didn't do it up here? You'd be comfortable with that? Okay, I think you'd be okay. Okay, so what about, now I need to graph my other line. So I have the 1/2 x plus 1. Jared, where's my y-intercept for that one? Yeah, at 1. So here I am up at 1, so I have that. And then Joyce, what's my slope? 1/2, okay? So my slope's gonna be 1/2. So Joyce, what do? Do I go, how would I graph that? Yep, yeah, so I'm gonna go up 1 over 2. So that's gonna go, if I go up 1 over 2, that puts me right here at 2, 2, which I already had a point there, so we just found an intersection. But then if I keep going, if I go up here, now I'm at 3, so up 1 over 2. So now I'm at 3, 4. Then if I go up 1 over 2 again, I'd be at 4, 6. Then if I go up here, I'd be at 5, 8. And then if I come up again, I'm going to be at 6, 10. Okay, so if I draw that right there, I can see, yeah, Luke?
Where are you starting that line at?
This one, my y-intercept at 1. Yep, and then I just go up 1 over 2, up 1 over 2, up 1 over 2, all the way. So for this one, yeah, Trey?
Does that mean you have 2 solutions?
It does mean I have 2 solutions. So we can see with this, I see I actually have 2 solutions. So sometimes you can have more than one. So it doesn't matter however many times your graph intersects, that's how many solutions you have. So my solutions, Darby, where would one of them be?
They would be at, would it be 1?
Sorry, this is bad points. So this one right here.
2, 2?
Yep, 2, 2. And then this one over here, I'd have,
That's 6.
yeah, 10, 6. Yep, so my 2 solutions, I have one at 2, 2, and then one at 10, 6, okay? And obviously if you guys had graph paper, your points would be a lot more accurate than what mine are up here, but you can just see, just follow your slope, plot your y-intercept where it's supposed to be, and then figure out where the graphs are gonna intersect. Aiden?
Would there ever be 3 solutions?
Maybe later on in the year, but not in this section, okay? Because we don't know polynomials yet, but then that will. Okay, but so not in this section. You'll have 1 or 2. Okay, so when you're doing your homework, 1 or 2. Any questions so far? You feel okay? Okay. What about if I give you an inequality instead of an equal sign? So this one, it says I have x squared minus 4 is greater than 0. So I'm gonna do the same thing. I'm gonna graph one side and graph the other. And then I'm just gonna have to think about like, where is this equation greater than 0, okay? So let's start by just graphing them. So if I graph x squared minus 4, Ashley, where is that graph shifted?
Where?
What'd you say?
Or?
Yeah.
The right.
4 to the right. Is it in parentheses?
No.
So instead of to the right, I'd go.
Down.
Yeah, exactly. So I know, so if I have x squared minus 4, so I'm trying to graph that. I have my x squared, that parabola, that U-shaped graph, and we're gonna move it down 4. So I know its vertex is now right here. It's gonna be at negative, or at 0, negative 4. So now we can go ahead and figure out a couple more points just by plugging them into our equation, just to help us figure out where they are. So if I plug 1 in for my x and solve it, that's gonna give me my y coordinate. So if I plug 1 in, I'd have 1 squared minus 4, which, Nate, what is that gonna give me? Yeah, negative 3. So when I'm at 1 on my x, my y is gonna be at negative 3. Okay, let's go ahead, let's put 2 in. So I'd have 2 squared minus 4 if I just plug 2 into my equation, which, Allison, what's that one gonna give me? So if I have 2 squared, yeah, 0, yep. I think you just didn't square it, so, yep, so I'd have 4 minus 4, which would be 0. So over here, I'd be at 2, 0. What about, Connor, if I plug 3 in, what am I gonna have? So if I have 3 squared minus 4, what would I have?
5.
Yeah, 5. Okay, so at 3, I'm gonna be up at 5. Okay, then one of the nice things about the quadratics is what happens on one side always happens on the other. So I don't need to actually calculate all these points. I know that they're just gonna be mirror images of each other. So I would have a point at, I had one at 1, negative 3. So I'm also gonna have one at negative 1, negative 3. Then this one at 2, 0, I'd also have one at negative 2, 0. And then at negative 3, I'd also have one at 5, okay? So then I can go ahead and just connect those points and draw my quadratic. Oh, that was really bad. Okay, so here's my quadratic. Is everyone okay with how we did that? No, questions? No, just not okay, Grant. Okay. Well, Grant, how would I graph the other side if I just have 0? How would I do that?
A line of 0.
Yeah, the other one's just gonna be a line at 0. So I have this graph and then I have this right here, okay? So those are my 2 graphs. Now, if I think about it, when it says x squared minus 4 is greater than 0, well, if it's greater than 0, wouldn't that be all the stuff up here? It'd be the same thing as positive, right? Everything above my x-axis. So basically, all I need to do is my solution, instead of it being a specific point, yeah, they cross at certain points, but all of this is greater than 0, isn't it? And all of this over here is also greater than 0, all of that's positive. So I would just, my answer would be, I would just write my positive intervals. So my graph is positive. I can say, well, where's this side over here gonna be positive?
Negative infinity to 2.
Yeah, negative infinity to positive or negative 2?
Negative.
Okay. Yeah, negative infinity to negative 2, so negative infinity on our x to negative 2 on our x. And then the other one, Aiden, this side over here, where is that positive?
From 2 to infinity.
Yeah, from 2 to infinity. Yep, so when my x is 2, all the way out to when my x is infinity. Okay, so my solution is this right here. So this is also the positive. It's also our solution. Okay? So instead of it just being a point, if we're dealing with an inequality, it might be like a range of numbers. So from negative infinity to negative 2 is positive. It like does what it's supposed to. It's a greater than 0, okay? Okay, then we have a word problem. So it says a motorcycle is 40 miles ahead of a car. So the motorcycle travels at an average rate of 40 miles per hour. The car travels at a rate of 60 miles per hour, and we're trying to figure out when the car will be ahead of the motorcycle. So we want to graph these. So if I want to graph these, so I have my car and my motorcycle. And let's go ahead, let's write equations for them. So let's see. Taylor, what do you think my equation for my car is going to be? What would my slope be? Yeah, it'd be 60x, right? Do I need to add anything with it, or where do you think its y-intercept would be? Yeah, 0, because it just starts at a starting point. Yeah, yep. So the speed is our slope. So our car, it just travels at 60 miles per hour. So I have 60x. And I don't have a y-intercept at all because it's just going to start at 0, 0. Okay, then Darby, what about my motorcycle? What would that equation be?
40x.
Okay. Do I need to add anything with it?
I don't know. No, yes.
Let's think. Let's start to draw our graph. So if I'm drawing my graph, so here's my car starting out right here. So this is going to be, if my motorcycle's starting 40 miles ahead, then would it also start down here?
No, it would start at the 40.
Yeah, it's going to start up at 40. So my y-intercept would be 40. Okay, so my motorcycle starts up here at 40. So here's my car starting at just a starting point. Here's my motorcycle starting 40 ahead of my car. Okay, so then we can go ahead and figure out, like based off of how fast they're traveling, when the car is going to be ahead of the motorcycle. Okay, so if we just deal with our car first, my slope is 60x. So I know that would mean if I rise over run that I'm going to come up 60 and then go over 1. So I'd be at 60 and then at 1. Is everyone okay with that? Then after 2 hours, how high up would I be? Yeah, it's going to be all the way up at 120.
I don't think I'll be on board.
Okay, so at 2 hours, here I am at 120. Okay? So here's my car. Going really, really fast, so it's got a nice steep slope. Okay, now my motorcycle, it starts at 40, but its slope is only 40. So what would its next coordinate be? After 1 hour, where is it going to be at? Yeah, 80, thanks, Grant. So I'd be at 1, and then I'd be at 80. After 2 hours, where's my motorcycle going to be? 160?
120.
120. Yep, because I'm adding 40 every time. I'm going up. So I started here, and then I went up 40 over 1, because my slope is 40. And then if I go up 40 over 1, I would be at this point right here. So, can you guys see where those two graphs are going to cross each other?
2 hours.
Yeah, so at 2 hours, they're both 120 miles away from whatever starting point the car started at. So just to answer the question, the car is going to be ahead of the motorcycle after 2 hours. So they're at the same spot at 2 hours, but after 2 hours, that car would be ahead. Okay? Do you guys feel comfortable writing your own equations with something like that?
I don't know, why someone to be done
Maybe it's a county road. I don't know. Okay, so the next thing, guys, grab your graphing calculators and we're gonna let the graphing calculators do some of the work for us. Okay?
Go get it.
30, go get it. Great, number 11. Whoa. Oh, you got this calculator 34. You said shades of guessing.
What number is it?
I don't want to do what they're doing.
It could be algebra. Or it could be, it's probably
It's got an
trig.
X, it's got an X thing, a Y1, a Y2.
Yeah, that's algebra. That's what we're
We
doing.
gotta do this?
Yeah. Okay, you guys. So sometimes all of these examples have been really nice. They've been nice whole numbers, right? We haven't had any weird crossings. Well, if I had some graph and like, say I had some like absolute value graph and then I had some straight line. Well, I have no idea if these are whole numbers. They might be weird decimals. Sometimes things don't cross on like perfect numbers, okay? So instead of us like having to like estimate what it's gonna be, we're gonna let the calculators just do the solving for us. So here's our steps. I'm gonna give you the equations to put in your Y1 and your Y2. So if you turn your graphing calculator on and then go to your Y equals, and then in your Y equals, we're gonna do this example first. So in your Y1, type negative x squared plus 8x minus 13. And then in your Y2, type absolute value of x minus 4. And remember the way to get those absolute value signs, if you go math, and then over to number, and then abs, and then x minus 4 inside those absolute value. Okay?
Alright, start from scratch.
Yeah, you're gonna have to say that.
Yep, and then go ahead and graph it.
And then for our Y2, we do that.
Yep, so then Y2 type in absolute value of x minus 4. And if you know what you're doing, help your partner. You guys, there's only one of me and I sprinted around all morning trying to help everyone. Okay, so if you got it, help your partner. Okay, okay, so go ahead and hit graph. And so I can see that everybody graphed these graphs for you.
Baylor, come here. We don't know how to get the black side.
Oh, let me find out.
Alright, looks good. Once you have your graph, I want to make sure we see our graphs, that they look good. Okay? Hold yours look good.
Knock that off. It's my baby on the
Okay, I think everyone's there.
What seems on
Bang it. We'll cut the keys.
Don't cut this stuff.
So now go ahead and do that.
Good way.
And then now take it.
Oh, yeah.
Now I gotta do this.
No, that one looks fine. Okay, anyway, if you're not there, raise your hand. We don't want, we want them in separate things. So then this one down here, yeah, we don't need that equation. So then math. And then go over to number absolute. And then now type in x minus 4. Okay, so math. And then over to number. And then abs. And then x minus 4. Are you good, Jalen? Okay. Do all your graphs look the same? Yep. And then go ahead and graph it. Okay, awesome. Anyone not there? I think I checked everyone. Okay, you guys should all be looking at a graph of, let me draw it up here. Okay, so your graph looks something like, we have a quadratic like this, and then we have our absolute value in here. Is everyone okay with this?
Yeah.
Yes, so we have two intersections. Does everyone see that? So we're trying to calculate two solutions. So to get our graphing calculators to do the work, these are our steps, okay? So we're gonna do this all together. So we did 1 and 2. We put our equation in our y1 and then we put our other one in our y2. So now the next thing, so stay with me, we hit second, and then calc, which is the trace button. It's right next to graph. Does everyone see that?
Right next to the graph.
Okay. Now it says go down to number 5, which says intersect, because we're trying to figure out where these two graphs intersect. So go ahead and hit enter on number 5.
Got it.
Are we all there? Okay, so this is really where it gets tricky, so please listen, okay? Because I don't want to make you guys do this all, like, let's let the calculator do the work. So if we can't figure out how to do it in the calculator, we're going to have to do it the long way. So let's figure this out, okay? So what it says use your arrow keys to work the cursor around until it's right next to the intersect on the first line and hit enter. Okay, so we have two intersects. We are just going to focus on this one right now. So we are going to hit enter on this point 3 times. So basically, if you take your cursor, your little left and right, you should see a cursor start moving. It's probably going to come up if you hit come up on your quadratic. And once you get to the point where it intersects, once your cursor, it's flashing on top of where that intersect, you hit enter. Are we all okay? Yeah, okay. So now on the bottom it says second curve. So because we already used the parabola, we used this quadratic, now I need to make my cursor jump over to the absolute value line, okay? Because you can't use the same line twice because we need 2 separate lines. So in order to do that, we just use if you use like this left arrow key, you should now see your cursor moving along your absolute value graph. Okay? Once you see it on your absolute value graph, go to that same point that we just used before and hit enter.
Same point as before.
Okay, so intersect now.
Yes.
Now it's the second curve, and so now you enter on our absolute value and then hit enter. Okay, now once you've gotten there, for those of you who are still with me, it should say yes on the bottom, and you're just going to hit enter again. You should be right on that same point. So you're using the same point 3 times, and then once you hit enter, the coordinate should pop up on the bottom, okay? Yes, sir.
What did you get? You did something wrong. Huh? 2.7. Yeah, I know you. 2.69. Second.
So for those of you who might have popped up, let me tell you what the answer is. Okay, so this coordinate right here, it is 2.69 ... and then 1.30 for my y. So if these numbers are on the bottom of your screen, you did it right. If you did it right, please walk around and help your neighbors. There's only one of me. Raise your hand if you didn't get it, and I'll come to you. Oh,
Okay.
Anybody need help?
I don't know what you just said now.
That's close.
I did like what you said. I feel like I make it. Yeah, you did. Not quite. No, I'm just like nailing that lemonade stuff.
Did you get it?
Oh,
I did not.
that's horrible.
Pretty good.
Oh.
All right, I think that's good enough. Your number 9.
I don't know if I did it right.
Oh, great. I'm
It's like, well, I don't know for sure how to do that either.
Good circle. Is this?
I could have walked around and get
He's trying to push me around. He's trying to push me. Dexter was like, look, he started pushing me around. I was just trying to hit him. I hate
All right, is anyone still struggling?
Does it have to be the exact number? Because I like tried and I'm gonna redo it, but
No, I
standing on the pipe. Yeah, you're just bad.
How do you go back?
I fucked up.
okay, so that's because they didn't give me the gas thing, so they kept giving me the second number gave it to me.
So you maybe didn't use the intersect, you might have used that. So they're ones, they're super good.
Okay, so we will end there today. I hope we're gonna practice. There's like one more example tomorrow. So before I set you loose, I want to make sure that we all feel comfortable with this. So we'll finish up tomorrow that other example. But otherwise, you guys can get started on your IXL tonight or your homework.